All right. So, hi guys. I recently had a need of finding a free IK tool somewhere on the internet. I'm a poor developer and I'm kind of trying to have fun with game development. So, yeah, I browsed all over the internet and finally ended up on this website, the Buchhofer.com, and this guy had like pretty decent IK solver, which was which was doing pretty well for Unity. Like not so great though. I had to do like little optimization and little optimize the CPU performance and garbage collection for this script, but eventually it worked out fine for me. So I don't know. I was thinking if they have this thing available like publicly, I think it's fine to like optimize it and like also like give them credit and redistribute the script. I don't know. I'm not really sure, but yeah, if you're going to use it commercially, I think you have to check out with them and yeah, make sure that you are not breaching any IPs or anything. So yeah, let's get into it. When I downloaded like this file, ikccd2d.zip, weird name, I got this four scripts, but I ended up using only two of them, ikcontrol and iksimple. And let me first demonstrate how the IK works, and yeah, let's get into scripts and performance afterwards. So this is basic bone structure, and yeah, I'm gonna disable my mother I. Sorry, I'm not a native English speaker. I'm gonna disable other IKs. I'm gonna work with one, just like this guy. So here I have like this root bone over here, which is kind of basic, like the root of everything. And this is like another bone, like knee and a foot, or kind of thing. It would be a knee and a foot for my spider in my game. So it's always trying to reach out for the target over here. So it's kind of stretching, and yeah, if I'm on the target, like different areas, it's kind of trying always to stretch it out towards the target as far as it can. And the second control for this object is the up guide, like this guy tagged with up marker. And what it does is kind of ensures the plane where all the bones exist in. So basically the plane is defined by target, up, and root bone. And all the other bones are exist in this like one single plane in the world. So usually I would I would have this up like directly above my spider body, because I would only want my legs to go up and down, up and down. And if I like move it around, I just want the knee to face up all the time. Kind of spider tank thing. I'm pretty sure you have seen spider tanks. So this is my performance over here, which is giving me huge physics spikes for some reason. Like this orange thing is a physics spikes. And I've been Googling around and I found out that the Unity I'm using, the Unity version I'm using, 5.5, 5.3.5, I'm not sure. Yeah, 5.3.5 F1 has some issues with physics, and other guys have been like complaining about it. It's not my fault. We're not using physics at all in the script. There's no physics involved at all. So what I'm interested in profiler here is scripts and garbage collection, like the blue one and dark green or something, which are like pretty low. The scripts never gets more than like 1.5 milliseconds. It's usually below one milliseconds, which is like totally fine for my project. And this is only for one IK script, so I'm gonna enable all of these guys, like 50 more IKs over there. And I have this one script that's kind of taking the local position of up and target of my source IK and kind of copying them, like pasting them all over those guys. So if I move my target, like it's gonna in update loop, it's gonna copy it to like all of those guys, and same with up direction. Now you get the point. So the performance here, like okay, let this physics spike pass. The performance on updating these things is like one point. Wait, it's more than that. It's like I saw like 4 milliseconds top when I was testing it earlier today. So yeah, if it's stationary, it's like if target and up are not moving, that the computation is not being done. Like there's no need to compute it. So that's kind of a huge optimization. But like when I'm moving them, like like they're stationary, but I move them around like during like this period. When I moved, like it got like 1.4 milliseconds in scripts, and like to 3.2. And this is again a physics spike. I'm not really care about. I'm not caring about that. So that's pretty good for me. I don't know about you. So if you want to download it, I'm going to provide the link in the description in the video. So yeah, that's pretty much done with the optimization, the performance part. Let's get into the scripts. Okay, these are the other trials that kind of didn't really work out for me. So in IK control script, which is like this one, we have only two functions: start and update. In start function, the major thing is like creation and initialization of IK simple class, which is this guy. And in update, we're like taking that object we just created in start and like trying to solve, solve the bone structure for the current frame, and doing it only if the up target and target position have changed. Like basically only if this and this guy have either of them kind of moved or scaled down or rotated or something like that. I'm just using their position for now. I don't really care about the scale or rotation. So here in IK simple class, this is this guy. This is the one that's being called over here in update from IK control, and this is basically the same script that you can see from Buchhofer's website. The only thing I've done is like little optimization for garbage collection and introduction for up vector up here. So first garbage collection. For that, what I did is I took all these private variables and took them out into class level and like made them private. All these guys were declared in solve function, and the thing is, because they're declared every frame, like we're calling this solve function every frame, and those guys are declared every frame. What this does is kind of this causes the garbage accumulation. So like every frame, we're kind of using all these guys and then discarding them at the end of the frame. Same with these guys, like the arrays are a nightmare for garbage collection. So the good side of these things like initialization and all these guys being into solve function was it was allowing me to change the bone structure at runtime. Yeah, basically like right now I have like 3 bones, but I cannot change it at runtime. I'm just telling to the script, hey, the target bones are this and this, and yeah, that's it. Work with that. Before that, the target bones were fed into solve function over here, which is not really what I want. I'm not going to change the bone structure of the spider tank at runtime at all. I'm just going to like introduce a model at the start of the game, and that's it. Boom, solve it. So that's like I'm saving up a lot of garbage collection. I haven't done much about CPU and performance optimization, except that like I'm using square magnitude. Like before that, there were magnitudes here. Whoops, sorry. Magnitude, yeah, they were using magnitude, and it's a general rule of thumb, like for optimizing your scripts, trying to use square magnitudes everywhere you can, because magnitude is square root of square magnitude, basically, and square root is like very expensive for CPU to calculate. The square magnitudes are like really cheap to computate, and like that's why they are actually in the vector3 class structure. Like try to use them instead of magnitude, kind of saves some CPU. And try not to normalize stuff. There was some normalizing stuff here, like I don't know. I cannot find them anywhere, but yeah, try to like not to normalize vector threes if you don't have absolute needs. Like quaternion angle axis is kind of supposed to take in normalized vector, but it's supposed to take a normalized vector if you're doing it on a blackboard, not for Unity. Unity doesn't really care about normalized vectors. You can like give him a vector of any length, it's gonna do fine. And yeah, finally down to these 4 lines. These 4 lines just ensure that the bone structure, the IK solver can take into account the up transform. So it's kind of and these multiplications, this multiplication just ensures that these guys are taken into account into final rotation. If you're a math freak, you can dig in and kind of see what's going on. I'm not gonna go into details. Basically, those 4 lines ensure that we can take into account the up guy, this up transform, and that's all I wanted to say today. I'm gonna provide the link in the description for downloading these guys, and make sure you contact them if you want to use these scripts into your commercial projects. And I'm not sure about that. They don't have their license listed anywhere. The scripts themselves have. They're saying that, like, you see the terms of use documentation for this project, but like your project doesn't really have any terms of use documentation. But yeah, make sure if you want to use this project, like, you have sufficient rights. But I'm just hoping that if they have this publicly available, I can just modify, optimize, and give them credit, and also redistribute it publicly. I'm not taking any money, and I'm not commercializing this project, so I'm pretty sure I'm fine about that. Fingers crossed. So yeah, thank you. See you later, hopefully.